Okay. So we're going to wind up with division of fractions. We've got 15 minutes left, and I'm going to give you as much as I can. You guys know, we already heard, I love it. It's copy, dot flip, copy dot flip. That's one way to put it. We could type it up a little differently to divide fractions. Keep the dividend the same. Change division into subtraction and change the divisor into its reciprocal. That does not quite come as trippingly off the tongue as copy dot flip. So this is one way to write the rule. This is another way to write the rule. Oh, not subtraction. What am I saying? Multiplication. Change division into multiplication. There's actually a rather famous poet who has taken this on, and his way of saying it is the following. There's no need to reason why, just invert and multiply. There's no need to reason why, just invert and multiply. Well, that's great, except do you invert both of the fractions? Do you invert the first one? Do you invert the second one? Anyway, I mean, he's just being silly and clever. But that's kind of how we feel sometimes, right? There's no need to reason why. Just follow the rules. There's no reason to think about it. Just invert and multiply. Okay, so just don't even write this down. I'm just saying fractions are the most complex type of number studied in elementary school, and division is the most complicated operation. So when you put the two together, then things really get out of hand. And so we are going to look at the why. And I kind of just said in here, you know, as teachers, you need to understand things more deeply than your students. That's just how it is. If you're going to explain things to people and diagnose what might be going wrong, you need to be able to explain it more deeply. So we're going to be focusing mainly on 1/2 divided by 1/6. And I'm going to show you in as many ways as I possibly can in the next 12 minutes. So 1/2 divided by 1/6, from what you guys told me earlier, this is copy, so a half stays the same, dot, division becomes multiplication, flip, so 1/6 becomes its reciprocal, which is 6/1. This gives us 6/2, which reduces to 3. Ooh, that feels unexpected. We've got a 1/2 and a 1/6, and when we divide with them, we get a 3. We get something that's bigger than either number that we started with. And so I am once again going to switch over to the other camera and give some support for why this is. So let's go to the webcam. There we go. Woo! All right. Okay, so we've talked about these a little bit before. I'm going to have the hexagon represent one whole unit. Therefore, the trapezoids represent a 1/2. I'm going to try to do this spotlight thing again. I'm not sure if this is making it bigger for all of you, but I hope so. Okay, so these are a 1/2, and then these guys are 1/6, because I can put together 6 triangles and they give me 1 hexagon. So 1 hexagon splits into 6 triangles. So these are 1/6, these are 1/2. So we've got half and we've got sixths. And I want to divide a half by a sixth. Well, division means goes into. How many times does 1/6 go into 1/2? In other words, how many 1/6 will fit into a 1/2? Sometimes teachers even call it Gesinte. Gesinte. Okay, so I'm matching this up as close as I can here. Oh, I see room for one more. It's 3. And isn't that the answer that we got? I don't know about you guys, but I love that illustration. It doesn't really tell us why, but it supports the fact that it works. I remember seeing this when I was at a conference after I was already a teacher, and nobody had ever shown me anything like this before, and I just about fell out of my chair. So I don't know if you guys are quite as excited as I was, but when I first saw that, I was like, wow, that's really cool. I'm going to go back to gallery view and go back to the notes. And we'll just do as much as we can. So are you guys seeing the notes again?
Yes.
Yeah, cool. Thank you. So that was an example of using manipulative materials. There are other materials you could use. What I used were pattern blocks. And they're not super flexible, but I do think they're nice, and they're especially good for an introduction like that. This is based on the idea of goes into. And I don't know if I'm a fan of this or not, but some teachers actually call division Gesinte. Okay, you guys, we're doing the Gesintes today. I mean, sometimes when we use a clever little thing, it helps our students, like, you know, feel playful and get into it. So that was that. That's what you just saw, is using manipulative materials. The second one is inverse. It's the idea of inverse with operation and number. Now, this is more helpful when students have already worked with negative numbers. So it's more helpful in the higher grades than in the lower grades. But you know that 7 minus -2 can be rewritten as 7 plus +2. And usually we do that by going zing, zing, right? We don't actually rewrite it. We just go kaboom, kaboom, or whatever sound effects we make when we're doing that. But you know that you can change subtraction into addition, and you can change the number behind it into its opposite. Well, okay, that's the inverse of the operation and the number. Well, if it works for that, then why on earth shouldn't we do 1/2 divided by 1/6 becomes 1/2. Let's change division to its inverse, which is multiplication. And let's change the fraction to its multiplicative inverse, which is a reciprocal. And this is a straight up correlation. The same reason why you can make this change up here is exactly the reason why you can make this change down here. And it may not feel like it, but what's changing is opposite operation. Opposite, I shouldn't say opposite, I should say inverse. But here too, we went for the inverse operation and the inverse number. Again, that's for older kids. That's kind of a support. Well, if we can do this with adding and subtracting, what about multiplying and dividing? Okay. This one to me is the most impacting, but it's also kind of advanced. But I'm halfway doing this for you guys, and I'm halfway doing it for your future students. So if you're still kind of like, I still don't see why, well, I can show you more. I can do some more. Actually, I didn't want to start with that. I was going to start with just 1/2 divided by 1/6, which, by the way, a division symbol is a fraction bar. Now at this point, we might start freaking out because now we've got what's called a complex fraction. And I don't know that I would do this to a third grader. Okay, but just for you guys, it would sure be nice if the number down here was a 1, because anything divided by 1 is like you divide by 1, that 1 basically disappears. Well, in order to make that a 1, I could multiply that by the reciprocal, and whatever I multiply by on the bottom, I have to multiply by on the top. And so what happens is the bottom just becomes a 1, and anything divided by 1 is just itself. So this becomes 1/2 times 6/1, which is just what we have on top. So I set it up. I did what I needed to do in order to get the denominator, the bottom, to just be a 1. So I could have carried that over here. It's this whole thing divided by 1. But anything divided by 1 is just itself. So that's another way to think about why. I'm going to take just a moment here because we've got about 4 minutes. Okay. I think I'm going to skip maintaining the value of the quotient. I'm going to skip that. I'll talk about that, but I might do it next time. Getting a common denominator. So these are, I'm jumping to some other approaches here, kind of skipping over some stuff because of the time. It's not necessary, right? We've established that. We've been doing 1/2 divided by 1/6, like 3 times we've done it, and we never got a common denominator. But what if we did? 1/2 divided by 1/6. Like, if you get a common denominator, is it going to be wrong? Well, let's try. So common denominator would be 6 because that's the number that both 2 and 6 go into. So when I rewrite this, it becomes 3/6 divided by 1/6. I'm not going to do the flippy thing. I'm going to think of it this way. 3/6 divided by 1/6. The answer to that is simply 3. Or I could look at it another way. I could say 3/6 divided by 1/6, right? Because a division symbol could be written as a fraction bar. The 6ths cancel. 3 divided by 1 is 3. Isn't that the answer we've gotten all along? It's actually shorter. You don't have to get common denominators to divide. But seemed to me this might. So it doesn't make it wrong. You can do that. And it might even be easier in some cases. So here's the thing. I'm noticing that we're in our last minute. I hope that I've given you some really good supports for multiplication and division and why they work the way they do.